Hello everyone. Today we are gonna discuss and solve problem number 9 from NeetCode 150, which is longest consecutive sequence. Let's jump into the problem. So this is the agenda of the session today. Understand the problem statement first, then walk through the examples, then discuss the brute force approach, and at the end of the implementation of it, we will discuss the time and space complexity. Then we will discuss the optimal approach and we will code the optimal approach. Finally, we will discuss the time and space complexity of the optimal approach. This is the agenda. So let's understand the problem statement. Given an unsorted array of integers nums, return the length of the longest consecutive element sequence. You must write an algorithm that runs in order of n time, linear time. Okay, constraints. Nums.length varies from 0 to 10 power 5 and nums of lies in between 10 minus 10 power 9 to 10 power 9. So this is the constraints. Okay, so let's walk through the examples. So this is our examples. So in this particular input, like 100 comma 4 comma 200 comma 1 comma, let me remove this thing, 3 comma 2, we can form three different consecutive sequence from this input element set, and among this three consecutive sequence, the first one giving the longest length, which is of 4. That's why the output for this particular input is 4, right? So consecutive means after the 1 it should be 2, right? After 2 it should be 3. That's why that means consecutive, right? So in this particular input, I could form, if you closely check, I could form only 2 consecutive sequence, right? So the length of the longest one is 7. You may be thinking like, I can also form a consecutive sequence, something like this. That's correct, but it's not making sense to form like this. Why? Because if one is exist, combining this 2 with that particular one set will give the better answer, will give the actual answer, will give the best answer that we are looking for, right? If one is exist, then forming this different another consecutive sequence will not be beneficial, right? It's a useless way, right? It's not useful. So we should not form like this. We should combine this 2 with that one existed consecutive sequence, right? So yeah, that's why I am telling I could form 2 consecutive sequence from the input element set, and among these 2 elements, 2 consecutive sequence, the longest length is 7, right? So in this particular input, I could only form 1 in consecutive sequence. If you see, if any element is duplicated, we will need to count that element exactly 1 time when we calculate the length value of that particular consecutive sequence, right? That's why the output for this is 9. And in this input also, if you closely check, we could form only 1 consecutive sequence and the length of it is 3. Here also 1 is duplicated 2 times, and we are we are counting exactly 1 time for this duplicated element. That's why the output is 3, right? So we understood the examples, like what we need to do. So I'll be traversing the inputs, right? If every element, I will need to check whether this is the starting point of the consecutive sequence. So in this consecutive sequence, starting point is 1. Here it is 100, here it is 200. So when I am at the current when I'm traversing the inputs, and in each element, right, during the traversal, I'll need to figure out whether this is the current element or not. How can I able to do that? If the particular current element minus 1 is not exist, then that is the starting point of the consecutive sequence. If that is identified, we can continue checking the consecutive elements present in that sequence, right? So if when I encounter 1 minus 1, which is 0 is not exist. So this means that this 1 is the current starting point of the consecutive sequence, right? So I will further continue checking the consecutive elements. right? In this particular sequence, like I'll be checking 2 is exist, then 3 is exist, 4 is exist, 4 plus 1 5 is not exist. So this is the only consecutive, this is one possible consecutive sequence, and the length of it is 4. So I'll keep this 4 in my answer variable, and I'll be, so first I'll be checking 100 minus 1 is 99, 99 is not exist. So this means that this 100 is the starting point. So I'll keep, so basically I'll have two length, one is the answer length, one is the temporary length. In this temporary length I'll be initializing 1, and I'll check 101 is not exist. So this, the 1 is the length of the current consecutive sequence that I am searching, right? So when I am at 4 minus 1 3 is exist. This means that this is not the starting point of the consecutive sequence. So I will need to continue. 200 minus 1 199 is not exist, means that this is the starting point of the consecutive sequence. I'll need to start searching for the consecutive elements from this point. Next I'll be looking 201 is not exist, so I cannot continue the process further. I have only encountered one length of the consecutive sequence, and this 1 is not the better answer because I've already kept the value as 4 in my answer variable. That's why 4 is the final answer that I'll be returning, right? So when I'll be traversing the elements, like, sorry, let me code this thing. So we will be traversing the input element, right? When I am at the current element, right? So let's see, int current element is equal to 0, and this current element equal to this nums of I. When I am at this current element, I will need to check whether this is the starting point of the consecutive sequence or not, right? So how can I able to do that, right? So that particular current element minus 1 might exist anywhere, right? It's unsorted array of integers. It might be exist anywhere of the given input. So what I can do, I can only do like this. I'll be start checking from the start. If current element minus 1 equal to if nums of j equal to current element minus 1, this means that this is not the starting point of the consecutive sequence. I should not continue from here, right? So do continue is equal to false. So here this do continue equal to true, and we will be breaking here. Finally, what I will be doing, if suppose do continue is true, then I will be continuing. If not, then what I will be doing, I'll need to keep one more variable, which is int answer is equal to 0, right? Here int sub answer equal to 1, and again I will need to, like, what I will be doing, boolean do break is equal to false. While do break is false, then I will continue. Here I'm gonna keep this particular variable as true, and the element that I'm looking for, like maybe int next element is what, current element plus 1, right? For again this next element might exist anywhere of the input array, right? So again I should start from the first, right? I cannot fix the starting point. I can only start from the 0th index. So if suppose nums of j equal to next element, then the next element will be next element equal to next element plus 1, and do break should be false, and I will need to break here, and I should not miss incrementing the sub answer. Why I am breaking here? Because the next element that I'm looking for might exist even before anywhere of the current jth index, right? That's why I should break here. Then this while loop will be continued. Then again I'll start checking the next element from this 0th index. So once this is done, I will keep the maximum value in the answer variable, this is the sub answer, and we will be returning the answer at the end. Let me submit this code. Before that, let me comment all these things. Sorry, comment these things. Run. Okay, let me submit. Okay, so if you, let's discuss the time complexity of this approach, this brute force approach. So here I'm starting I is equal to 0. Again I'm checking, I'm performing one more, I executing, I return one more loop, so it will be executed 2 times, like n square time, right? In the worst case, the time complexity of this approach is order of n square, right? That's why I'm getting the time limit exceeded error. That's one issue, right? Another issue is, let's say here I am having duplicate elements, right? So let me take this simple input. So here let's assume that I am having 0 some 3 times. In that case, our current algorithm will do like this, will repeatedly calculating the length of the consecutive sequence that could be formed, right? So this is unnecessary. This is a repetition of work, right? How can I able to avoid this repetitive work? If I can able to somehow perform the process on the unique element set, that is more optimal, right? So in order to do that, what I'm going to do is I'm going to create one hash set. So this is our brute force approach. Until this point, this is our brute force approach, and we are getting time limit exceeded error because this has to be optimized, right? So for that, we are going to create one hash set. I'm going to give a name of it as unique element set. So what we are going to do is unique element set dot add of nums of I, and we are going to iterate this unique element set so that we will be avoiding the repetitive work when we encounter the duplicate element. What I am going to do is current element. I'm going to give the name as current element, unique element set. So I'll be removing this current element value. Okay, let's run this thing. Okay, if you see, I'm iterating only the unique elements, right? You may be thinking why I am writing here. Also I can use the unique element. You might be thinking like that. That's correct. So maybe I will give a name as key 1, something like this, unique element set, and this key 1 is equal to current element minus 1, and do break it. Here also I could use this thing, which is integer key 2, then unique element set, and if this is key 2, then I could okay. So let me submit. I'm getting the time limit exceeded error. If you see, this is the not correct way. I have one utility method, right? I could use that thing instead of writing the iteration. What I can do, if suppose unique element set contains current element minus 1, this means that this is not the starting point of the consecutive sequence. I can continue here. So So here also what I can do, if suppose unique element set dot contains next element, then what I can do, this I can do the same thing here. In this way I'm so do break equal to true and unique elements. Okay, fine. So let me yes. So I am removing this manual loop to check whether the previous element of the current element has exist or not. I'm using contains method in the hash set class, right? If it is if this is, if the current element is identified as the starting point, then only this statements will be executed. If if it is not the starting point, then I'll be continuing. If this is the starting point, the next element that I'm looking for is current element plus 1, then do break is equal to false, and then it's not even needed to break. I can also comment this thing. What I can do, unique element set, if unique element set contains this next element, I'm going to write the same, sorry, here. In this way I can delete these variables. That's it. This should work. Do break is equal to false is wrong. No variable declared as do break. Okay. So worst case time complexity of this approach, of the optimal approach, worst case time complexity is order of n, and space complexity is order of n. This is for optimal approach. This is for optimal approach. Worst the same thing for the brute force approach. Brute force approach, first case time complexity is order of n square, and space complexity is order of n. I hope this is clear and this is useful solving this problem. Thank you.